Um, Hello everybody. Once again, my name is Ashraf Hamadi. This is the second portion of how to solve a Bernouilli differential equation. As I stated last time, the Bernouilli equation is always on the form of dy dx plus p x y fx y to the n power. Let me try to illustrate that with another example. We have, for example, let's see that example 2. Let's try to solve this equation, y prime plus y equal y squared. In this case, it's already automatically in the form of the general form. We don't need to work on transforming it into the general form, which is like dy over dx, p x y fx over. It's the same thing. Y prime can be transformed as that dy dx plus y equal y squared. And you can see that my p of x here is 1, and my f of x is 1 as well here. Therefore, we know that in order to do the Bernouilli equation, what we can do is is a substitution equation basically to the differential equation. That means we have to say that u equal y minus n. My n is always this one. The higher power is 2. That means it's going to give you 1 minus 2, which is going to give me y to the negative 1 in this equation. Now what we're going to do, we're going to try to try to solve for y. Y is going to give you what? It's the same thing. Y is going to give you u to the negative 1. Now, when you want the dy over dx here, as you can see, will give you what? You derive this one first, it's going to be negative 1, and the u to the negative 1 minus 1, which is going to give you du dx also here, which is going to give you something like negative u to the negative 2. Therefore, I can replace that into my equation here. Let me try to make a little bit space here. Let me try to make a little bit space here. And I have my u is negative u to the negative 2. Therefore, I'm going to try to replace it in my my initial equation. Let me erase a little bit to make. I mean, I have my dy du ds is equal negative u to the negative 2. And I have my u is equal y to the negative 1. With that in mind, I can a little bit erase here, and let me replace everything into my initial equation. Let me put my initial equation here. Y prime plus y equal y squared. That's my initial equation. And now I'll replace everything by u negative. Then I'm going to give you negative u to the negative 2 du over dx plus y. Y is what? U to the negative 1. We have admit to that. Going to give you u to the negative 1 square here. As you can see, I have my negative u square du dx here, u to the negative 1, and this is u to the negative 2. That is basically my new equation in the form of u. Now, what I can do is you can decide to divide both sides by negative u squared. By negative that. Now, my equation at the beginning, I can erase a little bit because I don't have enough space. I mean, my equation can be rewrite on this form. if I erase this one, because my equation can be rewritten on this form. Let's rewrite it like it was like that before. A squared du dx plus u negative 1 equal u negative 2 negative 2. That's what I have before. Now I said I divide everything by negative u squared and everything by negative u squared. When we do that, it's gonna give you, this one's cancelled, it's gonna give you du dx. This is divided by negative u squared, and it's gonna be minus here, and we have negative 2 here. Your negative 2 plus 2 plus 1 gonna give you what? Is that you inverting this one? Gonna get 2 times u to the negative 1. 2 minus 1 give you 1. Times gonna give you u. Times gonna give you u here, and this is gonna give you what? Negative 2. I have negative 2 here over negative 2 here. That will cancel. That will give you negative 1. You can see that my function is something like I can do now, because I know this form. I can use the integration factor. The integration factor, I can see that there is an integral function that I will call a mu of x, which is going to give you what? E to p of x. And my p of x is here is negative 1. You got it now. It's in my p of x here. P of x here is negative 1. We know those form of equation. That means my mu of x that I will use, my integration factor will be e to the negative x. The integral, e to the integral negative 1 plus here, and we're going to give you e. Integration of a negative 4 is going to give you x, negative x. That means going to be e to the negative x. That means my mu is equal e to the negative x. The integration factor. Therefore, I use that to multiply all of the number of this equation. I'm going to give you e to the negative x du dx minus e to the negative x u equal negative e to the negative x. As far as I go. Now, you can see that. Now, from that standpoint of view, I can do something here. I know that, like I showed you before in the previous video, I showed that when you have, is like the product rule. F times g is the same thing as when I want the derivation of that. I'm going to give you what? F prime g plus g prime f. That's what you have here. F prime. That's what you have. You have f times f prime is u, du over dx times g is and times the derivation of g prime, which is derivation of this one, times u. Therefore, I have this. This will mean, it will mean for you that it's going to give you e to the negative x u prime is equal negative e to the negative x. Now what we can do here, we want u by itself. That means we're going to try to, let me erase a little bit here, please. We're going to, that is where we are here. That means I'm trying to copy it again on top to you to see. You're going to see. Now, that means I have this at this point. Now, in order to find u, I would have to integrate both of them. If I proceed by the integration of this one going to give you e to the negative set u equal integration again negative x, negative e to the x, e to the negative x. We know how to integrate that because we can say that we can actually say that negative e to the negative x by by saying that let's put u equal negative x, another v equal negative x, and we replace inside, it's going to give you negative x. The integration for that plus c. Now that's what the same thing I'm going to get here. I'm going to give you negative times negative e to the negative x plus c. I don't know if you see that. Could you see that? I mean, basically, what I'm trying to say is going to give you, at the bottom here, a positive e to the negative x plus c. That is what I have. I'm going to be rewriting my equation again. It's going to give e to the negative x, u, equal e to the negative x plus c. Now, I want you divide both sides by that. U is going to give you e to the negative x plus c. Divide by e to the negative x. Divide by e to the negative x. And your u will be 1 plus, this one can go up, plus c to the ex. That is u. But what I want is my y. That is what we want. Oh, we know that u is equal what? Y to the negative 1 at the beginning of the equation. Because we substitute that, I'm going to replace it. That means my y is what? U to the negative is u to the negative 1. And that means my general equation, I'm going to give him a 1 plus c ex to the negative 1. Therefore, the solution for that equation that I wrote before, the solution of y prime plus y equal y square, the solution of that is y equal 1 over c plus c, it's 1 plus c to the ex. That's the general formula. And I hope this is gonna like help you to see another type of Bernouilli differential equation and the way we can solve it. Basically, the Bernouilli equation, we just have to remember the general formula like I said to you, and suppose that you use the substitution by saying that u equal 1 over minus n. And that's the way we're going to proceed to solve the Bernouilli differential equation. Alright, thank you. I hope this is gonna help you a little bit to see another time, and another video will come in soon. Thank you.